Welcome to Tech with Koushik. This is set 4 of our SC-500 Microsoft Security Operations Analyst Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 4. The next item is question number 125. This question focuses on managed identity lifecycle. Two Azure workloads have different identity lifecycle requirements. VM app should have an identity that is automatically removed when the VM is deleted. App A and App B must share one identity that remains available even if either application is deleted and recreated. Complete the identity selections. Statement 1. For VM app, configure the blank. Choose between 1. System-assigned managed identity, user-assigned managed identity, or manually created client secret. Statement 2. For App A and App B, configure a shared the blank. Choose between 2. User-assigned managed identity, system-assigned managed identity, or local service account. For Statement 1, select System-assigned managed identity. Its lifecycle is tied to the VM. For Statement 2, select User-assigned managed identity. Its lifecycle is independent, and the same identity can be attached to multiple resources. System-assigned means resource-bound lifecycle. User-assigned means reusable identity with an independent lifecycle. Question number 126 requires careful analysis. Pay close attention to every stated constraint. An Azure Key Vault contains an RSA key used by several applications through a versionless key URI. Security policy requires a new key version to be created automatically 90 days after each version is created. What should you configure? Evaluate each option against the stated requirement. Next, option A. A Key Vault key rotation policy with a rotate action triggered by time after creation. Next, option B. A certificate lifetime action on the key. Next, option C. A Key Vault access review every 90 days. Next, option D. A logic app that deletes the current key every 90 days. The correct answer is option A. A Key Vault key rotation policy with a rotate action triggered by time after creation. Here is the technical justification. Key Vault key rotation policies can automatically create a new key version after a configured time from creation. Applications that use a versionless key URI can resolve the current version, while older key versions remain available for operations that still require them. B. Certificate lifetime actions apply to Key Vault certificates, not cryptographic keys. C. Access reviews evaluate access assignments and do not rotate key material. D. Deleting the current key is destructive and is not the native key rotation mechanism. Remember this distinction for the exam. Key rotation creates a new version of the same key. It does not require deleting the key or changing the key name. Let us examine question number 127. The focus now shifts to backup immutability and soft delete. Let us first review the situation. A recovery services vault protects production virtual machines. Deleted backup data must remain recoverable for a safety period, and administrators must be unable to reduce retention or delete recovery points before their scheduled expiry. Which two Azure backup security controls address these requirements? Select 2. Choose every option that satisfies the requirement. Review each available choice. Option A is soft delete. Option B is lock the vault's immutability setting. Option C is Azure Bastion. Option D is storage account anonymous access. Option E is network watcher packet capture. The required selections are option A, soft delete, and option B, lock the vault's immutability setting. Soft delete retains deleted backup data for recovery after accidental or malicious deletion. Locked vault immutability provides irreversible worm-style protection that blocks destructive operations such as deleting recovery points or reducing their retention before expiry. The incorrect choices fail for the following reasons. C. Bastion is a remote administration service. D. Anonymous storage access would weaken security and is unrelated to backup retention. E. Packet capture is a network diagnostic capability. A useful examination rule is this. Soft delete protects after deletion. Immutable vault prevents destructive retention and deletion operations from succeeding in the first place. Now consider question number 128. Consider this scenario. A blob storage account has been migrated to Microsoft Entra authorization. Applications may continue to use user delegation SAS tokens, but account keys, account SAS tokens, and service SAS tokens must no longer authorize requests. Which storage account setting should you configure? The options are: Choice A, disable shared key authorization for the storage account. Choice B, enable anonymous blob access. Choice C, enable the trusted Microsoft Services Firewall exception. Choice D, regenerate both storage account keys every day. The best answer is option A, disable shared key authorization for the storage account. The key reason is setting the storage account to disallow shared key authorization blocks requests authorized with the account keys, account SAS, and service SAS. Blob requests authorized by a user delegation SAS remain supported because user delegation SAS uses Microsoft Entra credentials. The other choices do not satisfy the requirement because B, anonymous access removes authentication rather than enforcing Microsoft Entra authorization. C, the trusted services exception affects network firewall access, not authorization method. D, rotating keys leave shared key authorization enabled. The key takeaway is when allow shared key access is disabled, user delegation SAS remains the Microsoft Entra-backed SAS option for blob storage. Proceed to question number 129. We are moving to storage double encryption. Review the situation. A new Azure storage account must use customer-controlled key management for service-level encryption and must also encrypt data a second time at the Azure infrastructure layer. Which two configurations are required? Select 2. Identify all valid responses. Option A, configure a customer-managed key for storage service encryption. Option B, enable infrastructure encryption when the storage account is created. Option C, enable only secure transfer required. Option D, configure a service SAS for every container. Option E, enable blob versioning only. Select Option A, configure a customer-managed key for storage service encryption, and Option B, enable infrastructure encryption when the storage account is created. The requirement is satisfied because customer-managed keys provide customer control of the service-level encryption key. Infrastructure encryption adds a separate Microsoft-managed infrastructure encryption layer, producing double encryption. Infrastructure encryption for an account must be selected at account creation. The alternatives can be eliminated because C, secure transfer controls encryption in transit, not the requested second at-rest encryption layer. D, SAS controls authorization, not at-rest encryption. E, blob versioning protects object history but does not provide infrastructure-level double encryption. Keep this examination point in mind. Azure Storage Double Encryption combines service-level encryption with infrastructure encryption. Infrastructure encryption is a creation time account setting. Evaluate question number 130. Against every requirement. Identify the decisive requirement in this scenario. An Azure SQL logical server must use a customer-managed TD protector stored in an Azure Key Vault that uses Azure RBAC. The logical server already has a managed identity. Complete the configuration. The first statement reads, grant the logical server identity to the blank role on the Key Vault. The options for this statement are 1. Key Vault Crypto Service Encryption User, Key Vault Reader, or Key Vault Secrets User. The second statement reads, configure the Key Vault key as the server's the blank. The options for this statement are 2. TD Protector, Microsoft Intro Administrator, or SQL Auditing Destination. The correct value for statement 1 is Key Vault Crypto Service Encryption User. This role grants the cryptographic operations required by Azure SQL TD. The correct value for statement 2 is TD Protector. The TD Protector is the customer-managed key that protects the database encryption key. Exam tip. For Azure SQL TD with a Key Vault CMK, remember the server identity plus Key Vault crypto permissions plus the configured TD Protector. Question number 131. This question moves us into Defender for SQL servers on machines. Scenario. A company has SQL server instances running on Azure virtual machines and on-premises servers that are already Azure Arc enabled. Security teams need continuous SQL vulnerability assessment and database threat alerts across those machines. Which Microsoft Defender for cloud protection should you enable? Review the options. Choice A, Defender for SQL servers on machines under Defender for databases. Choice B, Defender for app service. Choice C, Defender for resource manager. Choice D, Defender for key vault. The required response is option A, Defender for SQL servers on machines under Defender for databases. The reasoning is as follows. Defender for SQL servers on machines protects SQL server workloads hosted on Azure virtual machines and Arc-enabled on-premises or multi-cloud machines. It provides vulnerability assessment and advanced threat protection for the SQL workloads. Now consider why the remaining options are unsuitable. B. Defender for app service protects app service workloads. C. Defender for resource manager focuses on suspicious management plane operations. D. Defender for key vault protects key vault access and operations. For SQL server running on machines rather than Azure SQL Pass. Recognize the Defender for SQL servers on machines component of Defender for databases. Question number 132. Scenario. An Azure VM subnet has an NSG. A custom outbound rule allows the VM to initiate HTTPS connections to the internet. An explicit inbound deny rule blocks unsolicited internet traffic. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, return traffic for an established outbound HTTPS flow can be allowed without a separate inbound allow rule. The second statement is, an NSG rule with priority 200 is evaluated before a matching rule with priority 300. The third statement is, deleting the outbound allow rule immediately terminates an HTTPS flow that was already established. Statement 1. The answer is yes. NSGs maintain connection state for allowed flows. Statement 2. The answer is yes. Lower numbers have higher priority. Statement 3. The answer is no. Existing flow records can continue. Updated rules affect new connections. Remember this distinction for the exam. NSG questions often test three things together: 5-tuple matching, lower number first priority, and stateful flow behavior. We will now analyze question number 133. Next, we enter the topic of virtual WAN routing intent. Consider the following scenario. A secured Azure Virtual WAN hub contains Azure Firewall. The network team wants all internet-bound traffic from connected branches and virtual networks sent through the firewall. It also wants private branch-to-branch and virtual network traffic sent through the firewall. Drag the routing policy to the traffic class it controls. Review the available source items. Source 1, Internet Traffic Routing Policy. Source 2, Private Traffic Routing Policy. The target positions are: Target A, internet-bound traffic from connected branches and virtual networks. Target B, private traffic between branches and virtual networks. Map Internet Traffic Routing Policy to internet-bound traffic from connected branches and virtual networks. Map Private Traffic Routing Policy to private traffic between branches and virtual networks. This is correct because virtual WAN routing intent uses the Internet Traffic Routing Policy to direct internet-bound traffic to the selected next hop, such as Azure Firewall. The Private Traffic Routing Policy directs private traffic, including branch and connected virtual network prefixes, through the configured security next hop. A useful examination rule is this. Virtual WAN routing intent has separate policies for internet traffic and private traffic, each with its own secured next hop. Review question number 134. Carefully. Begin by examining the scenario. An organization uses a site-to-site Azure VPN gateway connection. A compliance standard requires a specific set of IKE and IPsec algorithms and key strengths that differs from the Azure default proposals. The on-premises VPN device can be configured with the same values. What should you configure? Compare the following options. Choice A custom IPsec/IKE policy on the VPN connection. Choice B, a Microsoft Entra authentication strength. Choice C, an Azure Firewall application rule. Choice D, a private endpoint for the VPN gateway. The appropriate choice is option A custom IPsec/IKE policy on the VPN connection. Here is the technical justification. Azure VPN Gateway supports custom IPsec/IKE policies on supported site-to-site and VNet-to-VNet connections. A custom policy lets the organization specify the required encryption, integrity, Diffie-Hellman, and PFS parameters instead of relying on default proposals. The remaining options are incorrect because B. Authentication strength controls Microsoft Entra sign-in methods, not IPsec tunnel cryptography. C. Firewall application rules filter application traffic and do not negotiate VPN tunnel cryptography. D. Private endpoints are for private access to supported PaaS services, not for configuring VPN encryption. The key takeaway is if a VPN requirement names exact cryptographic algorithms or key strengths, look for a custom IPsec/IKE policy on the connection. The next item is question number 135. The focus now shifts to Azure Firewall Premium Inspection. Review the situation. An Azure Firewall Premium deployment must inspect outbound HTTPS payloads and must actively block traffic that matches supported intrusion detection signatures. Which two firewall policy configurations should you implement? Select 2. Select all answers that apply. Available choices. Option A. Enable TLS inspection and configure the required intermediate CA certificate. Option B. Configure IDPS in alert and deny mode. Option C. Configure threat intelligence to off. Option D. Add an NSG to Azure Firewall subnet. Option E. Configure a DNAT rule for all outbound HTTPS traffic. The correct answers are Option A. Enable TLS inspection and configure the required intermediate CA certificate, and Option B. Configure IDPS in alert and deny mode. TLS inspection lets Azure Firewall Premium decrypt and inspect HTTPS traffic by using a trusted intermediate CA certificate. IDPS in alert and deny mode performs inline signature-based detection and blocks matching malicious traffic. C. Turning off threat intelligence weakens protection and does not implement either requirement. D. Azure Firewall should not rely on an NSG on Azure Firewall subnet for these premium inspection capabilities. E. DNAT translates inbound connections and is unrelated to outbound TLS decryption and IDPS enforcement. Keep this examination point in mind. Azure Firewall Premium adds deep inspection controls such as TLS inspection and IDPS. Standard firewall rules alone do not provide these functions. Proceed to question number 136. A data access governance review identifies a SharePoint site whose content is broadly accessible inside the organization. The site must remain available to an approved Microsoft 365 group, but other users must be prevented from accessing the site, even if an item was previously shared with them. Which SharePoint control should you configure? The options are: Choice A, restricted access control for the site. Choice B, a Microsoft Sentinel automation rule. Choice C, Azure Storage Firewall selected networks. Choice D, Defender for endpoint web content filtering. In this case, select Option A, restricted access control for the site. The key reason is SharePoint restricted access control limits site access to members of specified Microsoft 365 or Microsoft Entra groups. It provides an additional authorization boundary that can restrict access even when users previously had sharing-based permissions. The incorrect choices fail for the following reasons. B. Sentinel automation manages security operations and does not change SharePoint site authorization. C. Azure Storage Firewall rules do not apply to SharePoint Online. D. Defender for endpoint web filtering does not enforce SharePoint site membership and access. Exam tip: for overshared SharePoint sites, identify the exposure with governance reports and use SharePoint access controls when you must constrain who can actually open the site. Now consider question number 137. Next, we enter the topic of agent ID owners and sponsors. Consider this scenario. An organization uses Microsoft Entra Agent ID and assigns both owners and sponsors to agent identities. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. A sponsor represents business accountability for the agent's purpose and lifecycle. Statement 2. An owner is the technical administrator who can manage agent configuration and credentials. Statement 3. Assigning a sponsor is the same as granting the sponsor the Agent ID Administrator Microsoft Entra role. The answer to Statement 1 is yes. Sponsors provide business ownership and lifecycle accountability. The answer to Statement 2 is yes. Owners handle operational and configuration responsibilities for their assigned agents. The answer to statement 3 is no. Sponsorship is an agent relationship, not a tenant-wide directory role assignment. Agent ID governance distinguishes owner, sponsor, manager, and Microsoft Entra administrative role. Do not treat them as interchangeable. Let us work through question number 138. Review the scenario carefully. A Microsoft Foundry agent uses supported moderated tools. The security team is designing controls for 3 different agent risks. Drag the guardrail intervention point to the risk location it should inspect. Begin with the following source items. The first source item is user input. The second source item is tool response. The third source item is output. The destination requirements are as follows. Destination A. A jailbreak attempt in the user's prompt before it reaches the agent. Destination B. An indirect prompt injection contained in content returned by a tool before the agent stores or uses it. Destination C. Harmful or protected content in the final answer returned to the user. The first mapping connects user input to a jailbreak attempt in the user's prompt before it reaches the agent. The second mapping connects tool response to an indirect prompt injection contained in content returned by a tool before the agent stores or uses it. The third mapping connects output to harmful or protected content in the final answer returned to the user. The requirement is satisfied because Foundry guardrails support controls at multiple intervention points. User input examines the prompt before model processing. Tool response examines content returned from supported tools before it can influence agent orchestration. Output evaluates the final response before it is returned to the user. Remember this distinction for the exam. Place the guardrail at the point where the risky content exists. Prompt, proposed tool action, tool response, or final output. The next item is question number 139. A company already has Defender for Servers Plan 1 on its Azure virtual machines. It now requires agentless scanning of machine disks and just-in-time VM access. Which 2 statements are correct? Select 2. More than one answer may be correct. Review the options. Option A. Upgrade the protected scope to Defender for Servers Plan 2. Option B. Plan 2 includes the Plan 1 capabilities and adds agentless scanning and JIT-VM access. Option C. Plan 1 already includes all Plan 2 capabilities. Option D. Defender for Storage must be enabled to obtain JIT-VM access. Option E. Foundational CSPM alone supplies Defender for Endpoint EDR integration. The choices that satisfy the requirement are Option A. Upgrade the protected scope to Defender for Servers Plan 2, and Option B. Plan 2 includes the Plan 1 capabilities and adds agentless scanning and JIT-VM access. The reasoning is as follows. Defender for Servers Plan 1 focuses on Defender for Endpoint EDR capabilities. Plan 2 contains Plan 1 capabilities and adds advanced features that include agentless scanning and just-in-time VM access. The other choices do not satisfy the requirement because C. Plan 1 is the entry-level plan and does not contain all Plan 2 features. D. Defender for Storage protects storage accounts and does not supply VMJIT access. E. Foundational CSPM is posture management and is not the Defender for Servers EDR plan. A useful examination rule is this. Plan 1 equals EDR focused entry level. Plan 2 equals Plan 1 plus advanced server protection such as agentless scanning, JIT, FIM, and premium vulnerability management. We will now analyze question number 140. Let us first review the situation. An AKS cluster keeps a public API server endpoint. Only administrators from the corporate egress range 203.0.113.0/24 should be able to connect to the Kubernetes API server. Complete the security configuration. Review Statement 1. Configure AKS the blank. The available choices are 1. API server authorized IP ranges, cluster autoscaler, or pod disruption budgets. Review Statement 2. Add the blank to the allowed list. The available choices are 2. 203.0.113.0/24, 0.0.0.0/0, or the Azure Load Balancer service tag. The answer to the first statement is API server authorized IP ranges. This feature limits network access to the AKS control plane API endpoint. The answer to the second statement is 203.0.113.0/24. This is the approved corporate source range in the scenario. The key takeaway is authorized IP ranges secure a public AKS API endpoint. A private AKS cluster is the alternative when the API server should have no public access path. Now consider question number 141. Review the situation. An app service hosted internal API must require users to sign in with Microsoft Entra ID. Unauthenticated API requests should receive HTTP 401 rather than being redirected to an interactive sign-in page. Which app service authentication configuration should you use? Available choices. Choice A, require authentication. Use Microsoft Entra ID as an identity provider and return HTTP 401 for unauthenticated requests. Choice B, allow unauthenticated access and rely on an NSG. Choice C, disable app service authentication and enable only outbound VNet integration. Choice D, configure HTTP 302 redirect for unauthenticated API requests. The required response is option A, require authentication. Use Microsoft Entra ID as an identity provider and return HTTP 401 for unauthenticated requests. This is correct because app service built-in authentication can require sign-in with Microsoft Entra ID before requests reach application code. For AP is HTTP 401 unauthorized is the appropriate unauthenticated request behavior when interactive redirects aren't desired. The alternatives can be eliminated because B, network filtering does not replace identity authentication for API callers. C, outbound VNet integration controls application egress and does not authenticate inbound users. D, HTTP 302 is commonly used for interactive websites, but does not meet the stated API requirement. Keep this examination point in mind. App service authentication handles identity at the platform edge. For AP is require authentication and prefer 401 over browser-style redirect behavior. The next key item is question number 142. We are moving to Logic Apps Secure Run History. Focus on the following situation. An Azure Logic Apps workflow retrieves a password from Key Vault and sends it to a downstream HTTP action. Operators must still be able to review workflow runs, but the sensitive values must not appear in the inputs and outputs shown in run history. What should you configure on the relevant trigger or actions? Focus on the distinction between these options. Now examine choice A, secure inputs and secure outputs. Now examine choice B, regenerate the workflow access key after every run. Now examine choice C, disable the workflow. Now examine choice D, create a Microsoft Sentinel incident. The correct answer is option A, secure inputs and secure outputs. Here is the technical justification. Azure Logic Apps secure inputs and secure outputs obfuscate configured input and output values in workflow run history. These settings are intended for actions that process passwords, secrets, keys, and other sensitive data. Now consider why the remaining options are unsuitable. B. Access key rotation changes endpoint credentials, but does not hide action data in run history. C. Disabling the workflow prevents processing rather than protecting run history data. D. Creating a Sentinel incident does not alter Logic Apps run history visibility. Exam tip. Request authentication protects who can invoke a workflow. Secure inputs and secure outputs protect sensitive data recorded during workflow execution. Let us examine question number 143. Begin by examining the scenario. An application gateway WAF v2 policy has managed rules enabled. A trusted internal integration sends a distinctive request header and must bypass managed WAF inspection for those matching requests only. What should you configure? Choose from the following options. Choice A, a higher priority WAF custom rule that matches the trusted header and uses the allow action. Choice B, a managed rule exclusion for every managed rule in the policy. Choice C, an Azure Firewall DNAT rule. Choice D, a lower priority custom log rule after the managed rule sets. The best answer is option A, a higher priority WAF custom rule that matches the trusted header and uses the allow action. Application Gateway WAF evaluates custom rules before managed rule sets. When a matching custom rule uses the allow action, WAF stops further custom and managed rule enforcement for that request and forwards it to the backend. The remaining options are incorrect because B, disabling or excluding every managed rule is much broader than the requirement. C, Azure Firewall DNAT is unrelated to Application Gateway WAF inspection logic. D, a log action records the match but allows evaluation to continue and therefore does not bypass managed rules. WAF custom allow or block actions terminate further WAF rule enforcement for the matching request. Log continues evaluation. Review question number 144. Carefully. This question moves us into Cloud Security Explorer. Consider the following scenario. A cloud security engineer wants to proactively find all internet-exposed storage and database resources in a multi-cloud environment that also have sensitive data indicators and high-privilege identity relationships. The engineer wants to build an ad hoc graph query rather than wait for a predefined attack path. Which Defender CSPM capability should the engineer use? Now examine the possible answers. Option A is Cloud Security Explorer. Option B is Just-in-Time VM Access. Option C is Microsoft Sentinel Content Hub. Option D is Defender for Storage Malware Scanning. The appropriate choice is Option A, Cloud Security Explorer. The key reason is Cloud Security Explorer lets security teams build graph-based queries against the Defender for Cloud Security Graph to find resource relationships and risks based on organization-specific criteria. B, JIT limits VM management port exposure. C, Content Hub installs Sentinel solutions and content. D, Defender for Storage Malware Scanning examines uploaded blobs and does not provide arbitrary multi-cloud graph queries. Remember this distinction for the exam. Attack Path Analysis finds Microsoft calculated exploitable paths. Cloud Security Explorer is the flexible graph query tool for your own risk questions. Let us work through question number 145. Review the scenario carefully. A Defender for Cloud recommendation flags one resource as unhealthy. An approved third-party control already mitigates the risk, and the resource should no longer reduce secure score. Another resource has an accepted business risk with no compensating control. Complete the exemption categories. For the first statement, for the resource protected by the approved third-party control, classify the exemption as the blank. Select from 1. Mitigated, risk accepted, or unhealthy. For the second statement, for the resource whose risk is explicitly accepted, classify the exemption as the blank. Select from 2. Risk accepted, mitigated, or healthy. Statement 1 should be completed with mitigated. The compensating control resolves the risk outside Defender for Cloud's tracked remediation. Statement 2 should be completed with risk accepted. The organization accepts the risk without claiming it has been remediated. A useful examination rule is this. Defender for Cloud exemptions are not all equal. Mitigated means resolved another way. Risk accepted means consciously waived. Question number 146. Next, we enter the topic of AWS Defender Connector Access. Scenario. A security team is onboarding an AWS account to Microsoft Defender for Cloud using the native connector. The team wants Defender for Cloud to use federated trust with short-lived credentials and to grant only the AWS permissions currently required by the selected Defender plans. Which connector option should the team choose during access configuration? Option A, least privilege access. Option B, store a permanent AWS root access key in Azure Key Vault. Option C, disable the cloud formation deployment. Option D, use an unauthenticated public endpoint between Azure and AWS. In this case, select Option A, least privilege access. The requirement is satisfied because the native AWS connector uses federated trust and short-lived credentials. During onboarding, least privilege access grants only the AWS permissions required for the capabilities currently selected, rather than the broader permission set intended to accommodate future features automatically. The incorrect choices fail for the following reasons. B. The connector is designed to avoid long-lived AWS root credentials. C. The AWS side deployment establishes the required roles and trust relationships. D. Defender for Cloud does not use unauthenticated public access for cross-cloud authorization. The key takeaway is for Defender for Cloud multi-cloud connectors. Recognize federated trust plus cloud-native roles. Choose least privilege when the requirement is minimum current permissions. Apply precise reasoning to question number 147. Analyze the scenario before evaluating the choices. An organization uses Windows Event Forwarding to centralize events from many Windows servers before sending them to Microsoft Sentinel. Drag each component to its function in the collection path. Some source items are not used. The source items are as follows. Source item 1, Windows Event Forwarding Subscription. Source item 2, Windows Event Collector Server. Source item 3, Azure Monitor Agent on the Collector. Source item 4, Azure Firewall. Now review the available destinations. Destination option A selects and forwards configured Windows events from source computers. Destination option B receives the forwarded events centrally. Destination option C sends collected events from the collector into Microsoft Sentinel according to the data collection rule. For mapping 1, pair Windows Event Forwarding Subscription with selects and forwards configured Windows events from source computers. For mapping 2, pair Windows Event Collector Server with receives the forwarded events centrally. For mapping 3, pair Azure Monitor Agent on the collector with sends collected events from the collector into Microsoft Sentinel according to the data collection rule. The reasoning is as follows. WEF subscriptions determine what Windows events are forwarded. The Windows Event Collector, WEC, receives those events. For the Sentinel Windows Forwarded Events Connector, Azure Monitor Agent runs on the collector and sends the collected events according to the configured data collection rule. Keep this examination point in mind. In a WEF design, endpoints forward to WEC first. AMA on the collector is the bridge from the Windows Event Aggregation layer into Sentinel. Proceed to question number 148. The focus now shifts to Sentinel ingestion transformations. Consider this scenario. A custom security data source sends JSON logs to Microsoft Sentinel. Before the events are stored, the SOC must discard health check records and mask a sensitive account number field. Complete the ingestion configuration. Review statement 1. Apply the filtering and masking into the blank. The options for this statement are 1. Data collection rule transformation, Microsoft Sentinel incident, or workbook visualization. Review statement 2. Express the transformation logic by using the blank. The options for this statement are 2. KQL, an NSG rule, or an Azure RBAC condition. For statement 1, select data collection rule transformation. DCR transformations operate on incoming data before it is stored. For statement 2, select KQL. DCR transformations use KQL-based transformation queries. Exam tip. DCR transformations are the pre-ingestion control point for filtering, normalization, enrichment, and sensitive data masking. Next, question number 149. A security Copilot workspace contains owners and contributors. An owner is reviewing plugin governance settings. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. An owner can restrict selected pre-installed plugins, so only owners can use them. Review statement 2. By default, every contributor can publish organization-wide custom plugins without an owner changing plugin settings. Review statement 3. Restricting a pre-installed plugin can affect embedded security Copilot experiences that depend on that plugin. Statement 1 should be marked yes. Plugin settings allow owners to control pre-installed plugin availability. Statement 2 should be marked no. Owner-controlled settings determine whether contributors can publish custom plugins broadly. Statement 3 should be marked yes. The plugin availability control applies to standalone and embedded security Copilot usage. Security Copilot plugin governance is owner-controlled and can affect both the standalone portal and embedded Microsoft security experiences. Proceed to question number 150. This question moves us into Security Copilot owner capabilities. Consider this scenario. A Security Copilot workspace contains an owner and a contributor. The team wants to assign workspace administration tasks without giving the contributor owner-level control. Drag each task to the role that can perform it under the default role capabilities. The items to be placed are: Source 1. Create and use Security Copilot sessions. Source 2. Manage capacity association and owner settings. Source 3. Configure whether contributors may publish custom plugins broadly. Match the source items to these destinations. Target A, owner or contributor. Target B, owner only. The correct destination for create and use security Copilot sessions is owner or contributor. The correct destination for manage capacity association and owner settings is owner only. The correct destination for configure whether contributors may publish custom plugins broadly is owner only. This is correct because both owners and contributors can create and use security Copilot sessions. Owner-only administrative capabilities include owner settings such as capacity association and the controls that determine whether contributors may add or publish custom plugins. Remember this distinction for the exam. Security Copilot contributor is a usage role. Owner adds workspace-level governance, capacity, data sharing, and plugin administration. You have completed Set 4 of the SC-500 Microsoft Security Operations Analyst Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.